Hello class. Today we'll be talking about tangent lines. Of course, we're talking about circles, tangent lines, angles, triangles in this video. So the first thing, a couple of important things, just if you forgot how we read angles. So if you have a triangle here, this triangle, let's say it's A, B, C. And you want to read an angle. So we have three angles, of course, in a triangle. We have this angle here. This is called angle A. This is angle B. And this here is angle C. So angle A, a lot of times when they write it, they would say it's angle CAB. That means, or angle. So it's not an L shape. It's kind of bent a little bit. And then at the bottom it's flat, and you would write either CAB or BAC, because if you are moving from C to A to B, you are gonna cross here, right? So this is the angle you're talking about in this case. So angle A is CAB or BAC, where the line pretty much bends. That's what the angle is. So this is our first angle that we are looking at. Second angle, angle B, you can imagine will be, angle B would be A, so angle, you could say angle A, B, C, or angle CBA. And finally, angle C, you can also say that angle will be angle ACB or angle ACB or BCA, angle BCA. So that's about angles. Triangles, you usually have the symbol of a triangle, and this would be triangle ABC, or of course you can say triangle BAC or triangle CAB. Doesn't matter what the order is, as long as you go clockwise, counterclockwise, it doesn't really matter. That's how we name triangles. So the other thing we can look at here, or we're going to be looking at, is tangent radius property. So as you might remember this, you might have forgotten, doesn't matter, but a radius is a line segment that goes from the center of the circle to any point on the circle. So in this case here, in this drawing, the radius is from O to P. That's the radius. So let's look at this theorem. So a tangent to a circle is perpendicular to the radius at the point of tangency. That is APO. So APO equals BPO, and that equals 90. So couple of words here, of course, you might be scratching your head wondering about is, what does tangent mean? Tangent is a line that is outside of the circle but touches the circle at one point. So the tangent here is AB, and it touches the circle at one point, which is P in this case. Okay, so the point of tangency is the point at which the tangent line touches the circle. That we call the point of tangency. Perpendicular, if you have forgotten, perpendicular means 90 degrees angle. So that's usually we write, instead of usually for angles we have an arc, but for perpendicular angles we just put a little square at the corner. So again, to describe what the theorem here says is, if you have any tangent like this one here, the point at which it touches the radius, that angle between them is 90 always. So if I draw one So this here is another radius. So if I draw a tangent line, so this here is a line that I draw there, and actually that wouldn't work, but a line right here, this is a tangent line. I'm gonna grab it and bring it so it touches at the point, at that point right there. So this is the point of tangency. So let's call this point, we had B, let's say this is point Q. So this angle right here is a 90-degree angle. Okay, so that's what this theorem says. So let's use that in some of the questions that you're going to be seeing in this unit or this assignment. So here it asks you to determine the measure of an angle in a triangle. Okay, so we draw a triangle. We have the circle. So the information we have here is we have the center of the circle, O, and it goes from O to A. That here is a radius. How do you know? Because it goes from the center of the circle to a point on the circle. And it says to you, it's going to be given to you also. It says point O is the center of the circle, and AB is the tangent to the circle. So they say this is the center. Any point from the center to the circle, that's a radius, and they tell you AB is a tangent. Okay, tangent, that means it touches the circle at only that point. And they tell you that the triangle OAB, this is a triangle, and angle we have AOB. So angle AOB, this angle right here, is 63 degrees. Determine the measure of OBA. So they want this angle right here. This is what we want to measure. I'm just going to put a question mark here. Okay, so to do that, we have one thing that we should know from before, the sum of the angles of a triangle is 180 degrees always. Every triangle, come up with one that's different, and I'll give you $5. So 180 degrees. We know this one is 60 degrees, but what about this angle right here and this angle? This is what we're looking for. To find out what this angle B or angle AOB is, we need to find this angle here, because we can't find if you have two unknowns, we can't really solve this problem. But a lot of you, if you have a good short-term memory, you remember that we talked about this angle a few minutes ago, and that's the angle so this is the point of tangency, and we talked about the theorem. The tangent to a circle is perpendicular to that radius. So perpendicular is what we're looking for. That means the angle is going to be 90. So this angle here, angle OAB, is 90. So you can be fancy and say angle OAB is 90. Okay, you can say according to theorem. You can do the easy math way of writing it, THRM, is 90. Therefore, angle, so 90 plus 63, that's given to us in the question, plus the angle we're looking for, AOB, equals 180. So 63, and so that's 153. So the angle AOB equals 180 minus 153, and that will give us 27 degrees. Okay, that's how you solve this kind of problem. Let's look at another one that you will see in this chapter. over this section. So using the Pythagorean theorem in a circle. Hopefully you remember this from last year. You've done this. We'll go over it here as well. So point O is given to us in this drawing is the center of the circle, and CD is a tangent to the circle. They say the length CD is 15 centimeters. The length OD is 20 centimeters. Determine the length of the radius OC. So what we're looking for is this radius right here. What is the measurement? We don't know at this point. I put a question mark there at the length. Give the answer to the nearest tenth. So the Pythagorean theorem again, easy math way of writing it, theorem. So that is a squared plus b squared equals c squared. So which one is a, b, and c? That's very important. They're not, you can't just pick as you wish. C is what you need to pick. The other two you can really alternate. Those are the legs of the right angle triangle, and we know this is a right angle triangle from the theorem, right? We know that the hypotenuse is always opposite to the 90-degree angle in a right angle triangle. So this here is the hypotenuse, so that is C. So you wanna make sure that once you assign this one, the other two doesn't really matter. So for this problem right here, we're gonna have C is gonna be 20, so that means 20 squared. Don't forget that. B, you can say this is B and this is A. If you switch the A and the B, it doesn't really matter. I'm just gonna do it this way. We said B is gonna be 15, so that's gonna be 15 squared, and A squared, we don't know that one. So A squared equals 15 squared, which is 225. Yes, the calculator agrees with me. 225 equals 20 squared is 400. Use a calculator. A squared, now 225, we subtract it from both sides, we end up with 400 minus 225. And A squared, this is where a lot of people make mistakes. A squared equals 175, but we don't want A squared, right? We want A, the length. So we need to take the square root of both sides. So A equals the square root of 175. That would be 13.228, and here they want to the nearest tenth, so that would be 13.2. So 13.228, we're gonna draw a line there when we round off, and that will say 13.2 centimeters is the length for side A, as we called it A, but OC equals 13.2 centimeters. Okay, that's it.